Hi, good morning everyone. The purpose of this video is to help you review forms of numbers and how to compare whole numbers. Okay, so let's hop into it. So going along with forms of numbers, numbers can have special relationships with each other. Okay, because remember, when you multiply a number by 10, it gains a 0. Okay, so like 5 times 1 is 5. But if you do 5 times 10, you're still multiplying 5 by 1. You're just gaining a 0 since it's a multiple of 10. When you multiply by 100, though, since it's a multiple of 100 and it contains 2 zeros, you would tack 2 zeros onto your base number. So 5 times 1 is still 5, but since it's a multiple of 100, we tack on 1, 2 zeros. Now, the reason we needed to talk about that is because numbers that are the same within a digit or within separate numbers have a special relationship, okay? Because we're in something called the base 10 number system, okay? So to find that relationship, we can follow 3 simple steps, okay? Let me show you what I mean. So for example, if we were asked to find what is the relationship between the 4s in 5,644, this is what we would do. We would first start by pulling out the values of those 4s, okay? So remember, the value of a number is how much that number is worth, and it's all based on its place value. Remember, the digit to the far right, it's in the ones place. Beside that is the tens place. It then goes to the hundreds place, the thousands place, and then the 10,000s place, okay? So to pull out the values of the digits, this 4 is in the ones place, so it's 4 ones. This 4 is in the tens place, so it's worth 4 tens, which is 40, because 4 times 10 would be 40. Base number 4 gains a 0 since it's a multiple of 10. Okay, so once we've pulled those digits out, they're the values out of those 2 digits. Those 2 digits are the same. Okay, so see, the base number stayed the same. It's 4 and 4. It just ended up gaining a 0. So we want to know what that gaining a 0 relationship is really looking like. So we're going to put an equal sign between the numbers because we want to make the smaller value equal to the greater value. Okay, so if we know this relationship over here, then we can figure this out. Well, what would we multiply 4 by to get up to 40? That base number didn't change, it just gained a 0. So I know to gain a 0, we're just going to multiply by 10. Okay, so the relationship between the two 4s, the relationship between the 4 in the tens place and the 4 in the ones place is that the 4 in the tens place is 10 times greater than the 4 in the ones place. Or you could say the value's 40 is 10 times greater than 4. Because we know 40 is greater than 4, and since they're side by side, they're the same digit, and we're in the base 10 system, we're just multiplying by 10 to get from the 4 in the ones place to the 4 in the tens place. Anytime you have 2 digits that are the same and they're side by side in the number, that relationship is always a times 10 relationship, okay? Because of how our base 10 number system works. So let's look at another example. What if we were asked, what is the relationship between the 7s in 577? Well, I know the 7s are the same digit, okay? They're just in different places, so they can have that special relationship with each other. So I'm going to start by pulling out the values of those 7s. Well, I know this is 7 ones, and this is 7 tens, so 7 tens is worth 70, 7 ones is worth 7. If I put my equal sign between them, I want to figure out what I can multiply 7 by to get up to 7D. Well, 7 and 7 are the same base number. It's just gaining a 0, and I know they're side by side in the original number. Therefore, it's going to be, again, a times 10 relationship. Okay? a times 10 relationship, just like we saw in the number here. The 4s had a times 10 relationship because to get from the value of 7 up to 7D, we are gaining 1 0. Okay, let's look at a different kind of one. Okay, what about the relationship between the 2's in 272? Notice this time the 2's are not side by side. There's a digit in the middle, but we're going to solve it the same way, same 3 steps. Step 1, pull out the values of the digits. We're going to pull out the values of the 2. Well, this 2 is in the hundreds place, so it's going to be worth 2 hundredths. This 2 is in the ones place, so it'll be worth 2 ones. Well, I see the base number's the same, 2 and 2. 200 just has 2 more zeros than the 2 does. So to gain 2 zeros, I have to multiply by 100. Because 2 times 1 is 2, and we would tack on 1, 2 zeros. So we could say the relationship between the 2's in 272 is that the 2 in the hundreds place is 100 times greater than the 2 in the ones place. And notice they're not side by side. They have 1 digit in the middle. And when there's 1 digit between the 2 digits you're trying to find the relationship between, that is always a times 100 relationship. So side by side, it's times 10, but if there's a digit in the middle, it'll be times 100 because they're 2 places apart. See, they're 2 places apart, so we multiply by 10 one time and then 2 times because 10 times 10 is 100. Okay? All right. So how many times greater is the 8 in the tens place than the 8 in the ones place? Okay? Same 3 steps. Pull out the values of the 8's. We know 8 tens is 80. 8 ones is 8. So to gain 1 more 0, we multiply by 10. And I know they are side by side. Now we can also find the relationship between numbers when they're in 2 separate numbers, the relationship between those digits when they're in 2 separate numbers. Check out this problem. 2 friends went to a laser tag competition. One friend scored 150 points. Another friend scored 85 points. How does the value represented by the 5 in 150 compared to the value, remember value's worth, represented by the 5 in 85? Okay, well, I'm just looking for the relationship between the 5's, how those values have a relationship with each other. So I need to pull out those values. Well, 5 tens is worth 50. 5 ones is worth 5. So to get from 5 up to 50, I'm gaining 1 0. So gaining 1 0 means I multiplied by 10. So we could say that the 5 in 150 is 10 times greater than the 5 in 85. Okay? All right, something else that we learned in this skill is expanded form and word form. Remember, expanded form is just the value or the worth of each digit in a number. Word form is simply how we say the number. So let's take a look at this number. I see that I have a 1 in the ones place, a 9 in the tens place, a 3 in the hundreds place, a 4 in the thousands place, and a 1 in the 10,000s place. So I'm going to write out the values of each of those digits. So 1 10,000 is worth 10,000. 4 thousands is worth 4,000. 3 hundreds, 100, 200, 300 is worth 300s. 9 tens is 90, and 1 1. Now, if you look carefully at this number sequence, you can kind of see a pattern. Here we have 4 zeros. Here we have 3, 2, 1, and no zeros. Well, if you're ever struggling with expanded form, always stack the numbers going straight down. This is what I mean. So right here in the 10,000s place, if it's 10,000, you pull that 1 down and just tack on zeros to hold the other places because this is 1 10,000. Same thing with the 4,000s. This is a 4 in the thousands place, so it's going to be 4,000s, and we just tack on zeros to hold the other places. This is 3 hundredths, 9 tenths, and 1 1. So just a little strategy to help you. Now let's talk about how to say a number, because if we can say the number, we can write the number, and we can read the number. So to say numbers, all you have to do is be able to read up to a 3-digit number. That's it. Because of our number system, all numbers are separated into groups of 3. So for example, ones, tens, hundreds, and then we group those 3. That is the ones period. So it's separated by the thousands period by a comma. So it goes ones, tens, hundreds, comma, thousands, 10,000s, and then 100,000s. So this set of 3, okay, we're pretending there's a digit here, is the thousands period, and this is the ones period. So to read a number, we only have to read what's before the comma, say the word thousands, since it's in the thousands period, and then we say the number after the comma, okay? But we don't say ones after that. That's just not how it works. We just leave it at that. So this is what I mean. So before the comma, I see a 1 and a 4. I'm not even going to think about the other 3 numbers. I just know a 1 and a 4 make 14. I can read the number 14, no problem. 14, and then, there's a comma, so that comma separates the thousands from the ones period. So we say 14,000, and then we read the rest of the number. So I'll cover up 14. Now I'll look at the rest of the number. 3, 9, and 1 is 391. So all I really had to do was read the 2-digit number of 14 and the 3-digit number of 391. I just added the word thousand between them to separate those periods. So to put it all together, this is 14,391. So just whatever's before the comma, say the number. Comma means the thousand, and then the number after the comma, 14,391. Okay, so what is the correct word form of this number? Okay, well, let's do what we just said. Read what's before the comma. Well, 3 and an 8, that's just 38. So 38,000, and then what's after the comma? Well, no hundreds, 2 tens and 4 ones, so that's just 24. So I need to look for 38,024. And if I look, C is the only one that says that. 38,024. Okay? All right. So what's the expanded form of 39,907? Well, I have 3 10,000, so I know I need 30,000. Okay, so C is going to be out. I need 30,000. Then I have 9,000s. Okay, so far A, B, and D are looking good. I have 900s. Ooh, A is showing 9 tens. I don't have any tens here. I have 900s. It's all about that place value. So A is out of there and D is out of there. So our best answer is B. There's 30,000, 30,000, 9,907. So, and remember, if you're struggling with expanded form ever, just stack the digits on top of each other and work your way down. So pull down the 3, tack on zeros to hold with the other places. Same with the 9, this 9, and this 7. And these 9s have a special relationship. If 2 digits are the same within the number, they have that special relationship. So let's look at it. This 9 in the thousands place is worth 9,000. This 9 in the hundreds place is 900. So 9,000 has 3 zeros. Okay? Here, get my camera right. But 900 has 2 zeros. So to get from 2 zeros to 3 zeros, we're just gaining 1 more zero. So to gain 1 zero, we multiply by 10. If you said 10, you're correct. And also the digits are side by side. And when they're side by side, it's that times 10 relationship. There's a number separating them in the middle. It's a times 100. Okay? So from 900 up to 9,000 gains 1 0, so we multiply by 10. Okay, speaking of gaining all of those zeros, this is another forms of number question. I like to call these tricky numbers, okay? This says, what is the standard and word form of 1700s? See, that's why it's tricky, because it's not just 700s, it's above that group of 10, it's 1700s. So that means we're going to have to work something out there. Then it's 14 tens and then 12 ones. These are all over groups of 10. So it's not just like our normal expanded form where we just have like 7 ones, 900s, 9,000s, 3 10,000s. It's in a weird form, so we have to solve what that is. Well, if we know how to tack on zeros, we can solve this no problem. See what I mean? 1700s is 17 groups of 100. So it's just 17 times 100. Well, when we multiply by 100, don't we just gain 2 zeros? So it'd be 1,700. 17 times 1 is 17. 1 0, 2 zeros. All right, well, what about 14 tens? 14 times, well, when we multiply by 10, we just gain a 0, so it's 140. But I can still solve it. 14 times 1 is 14. Tack on 1 0. And then 12 ones, well, that's just 12 groups of 1. 12. No zeros to be tacked on. So this is the number in expanded form, that kind of a weird expanded form, right? Because we've just expanded and figured out the value of the 1700s, the 14 tens, and the 12 ones. Well, if we want to put it in standard form, we want just the digits, so we need to put them together. So we're just going to add those together, okay? So when we add them together, we get 1,852. And I know that's the word form of the number because there's a 1 in the thousands period, 1,000, and then after the comma is just 852. Okay, so now let's look at one more. Okay, one more of these kind of tricky numbers. So here we have 2300s. What is 2300s? 23 groups of 100. 23 times 100, which is going to be 2,300, because when we multiply by 100, it just gains 2 zeros. What about when we multiply by 10? 3 tens. Well, we just gain 1 0. 30. And 15 ones. Well, that's 15 groups of 1. 15. No zeros to be gained. So when we add all three of those values together, we get 2,345. And that is also my word form because there's a 2 in the thousands period, and after the comma, 345. So the last thing we learned how to do in this cluster was compare numbers. Okay, so it says compare 25,853 to 23,871. Well, because of the way our number system works, if we want to compare whole numbers, we just have to compare each place value, okay? So we would compare the 10,000s with the 10,000s in each number, the thousands with the thousands in each number, the hundreds with the hundreds, the tens with the tens, and the ones with the ones. But when we're comparing, we always want to start with the highest place because aren't 10,000s worth a lot more than little ones? Because if we start comparing in the ones, well, this has more ones than this, but that doesn't really matter. We need to figure out the highest place first. So all I like to do is just stack the numbers on top of each other according to place value. Then we can get to comparing because remember, we don't want to start comparing in the ones. Because yeah, 3 ones is bigger than 1 1, but then when we get to the tens, ooh, this is bigger than this. So like, I wouldn't know where to start, right? Start from the highest end, okay? We have 20,000 and 20,000, or 2 10,000s and 2 10,000s. Well, those values are the same. So that doesn't help me compare the number. I need to move down. Uh-oh. 5,000 and 3,000, though, are different. Okay, so what's worth more? Well, 5,000 is worth more than 3,000. So because of the thousands place, 25,853 is greater than 23,871. The hundreds, tens, and ones did not matter in this question because, okay, even though these are the same, this is greater than this, it doesn't matter because this is just 7 tens and 5/10. Okay, this is just 3 ones and 1 1. Thousands are way larger than any of those values combined, right? So when we compare numbers, always start from the highest place. Okay, so what symbol correctly compares these numbers? Well, I have 14,025 and 14,114. Well, I'm going to stack my digits on top of each other and start from the highest place. Ooh, I have a 1 and a 1 in the 10,000s place, so that's the same value. That doesn't help. Move on. Thousands. Ooh, 4,000 and 4,000. Those are also the same. Doesn't help me too much. Move on. Ooh, this first number has no hundreds. This number has 100 though, and 1 is greater than nothing. So that means 114 is going to be greater than this number. So we would, to read this correctly, 14,025 is less than 14,114. Remember, kind of think about it like an alligator mouth. Alligators are real hungry. They want to kind of eat the greater value. So kind of think about it like that. You find the greater value and just make sure the mouth is facing that, and then you'll have your correct sign. Okay? I hope that video helped you review that skill, okay? Watch it again if you need to before you take your assessment. Good luck, you got this.